In this video, I'm going to go through the word problems that you have on your Chapter 2 in class review, and I'm going to go through them just kind of one at a time. So for this question, it says, an online jewelry store sells necklaces for $13.95 plus each, plus $1.95 shipping and handling for your order. So if Mario is going to purchase necklaces and have them shipped to his home, Mario's total bill is $127.50. Well, how many necklaces did he purchase if this was the total cost and they are $13.95 each, and then to have them mailed to your house, it just cost $1.95, not per necklace, just $1.95 for the shipping. So what I'm going to do is start with defining my variable, and I'm going to use the variable X, and since my question is how many necklaces, this is going to represent number of necklaces. And so my equation is going to be that the necklaces cost $13.95 each, so per necklace, plus $1.95 to ship, and the total cost is equal to $127.50. So now what I'm going to do is solve for X by subtracting the shipping fee out of the total. And if I use my calculator here, $127.50 minus $1.95 is going to be $125.55. So if it's $13 per necklace, $13.95, I'm going to divide by $13.95, and that'll tell me how many necklaces he bought. So divide, so I hit divide, 13.95. So it looks like X is equal to 9. So 9 necklaces. Okay, now, in the next question, it says that Blake is working and he's earning $17.35 an hour working as a store manager. Let X represent the hours worked and Y will represent the total cost in dollars. So notice there's a table over here. So number of hours worked and total pay. It says for number 5, complete the table to represent the relationship for number of hours of work. Well, if he works 1 hour and he gets paid $17.35, that will be his total pay. But if he works 2 hours, I'm going to take $17.35 and multiply by 2 for 2 hours worked. So that'll be $34.70. Now I'm going to go back. So if 3 hours... If 3 hours were worked, I'm going to add in another $17.35, so that'll be $52.05. And then I'm going to go back and multiply by 4. And if Blake works 4 hours, he'll earn $69.40. So that's for number 5, completing the table. For number 6, it says write an equation to represent the relationship. So if this is $17.35 per hour, I want you to think of that relationship MX plus B. So how much money does it say that he has to start? Well, it doesn't say he has any money to start that you're tracking with. So your B is going to be 0, and he's earning $17.35 per hour worked. So the 0 here is almost unnecessary in the equation. What you really need then for simplification is $17.35 per hour. And that is your equation. So now with this equation, you can sub in any number of hours of work into your variable. But I want to read this because I see there's something over here that I might need. If Blake is working 2 days and he works 10 hours each day, what will he earn after 2 days? Well, in 2 days, if it's 10 hours per day, that's a total of 20 hours. So I'm going to substitute in a 20. So where I was multiplying here in my calculator, if he works for 20 total hours, that would be a total of $347. Okay, here we go. Number 8, are these two equations equivalent? Why or why not? Actually, this is a good question, because if you think that 5 minus 2 gets you 3 and that should make this equivalent, we really need to talk about the importance of your order of operations and what they mean in math. The 5 subtract 2 times. So see this in parentheses here? That means your 2 is getting multiplied here, which means you have to address the multiply by 2 before you take 5 and subtract whatever you get. So this equation here, I'll actually go over this way. This would really be the same as 5 minus now 2 times x, and minus 2 times minus 4 would be plus 8. If that's equal to 2, is that the same as this? Well, no, it's not, because 3 times x and 3 times minus 4, do these match each other? And the answer is no, they are not equivalent, and it's because of order of operations. The multiply of the 2 has to happen before you can address subtract. So because of PEMDAS, the multiplying needs to happen before your subtract, which means they're not going to be the same. If you do order of operations incorrectly, you would say they're the same, but we don't want to make up math. We want to follow the order of operations. Okay, number 9. The area of this rectangle is 30 square inches, and the length is 5. So I'm just going to kind of think about a rectangle. If area is equal to 30 square inches, and I know one dimension is 5, what's the other dimension? So if I am supposed to use the formula area equals length times width, A is for area, L is for the length, W is for the width. Given this information, explain which variables should be isolated. Well, if area is equal to a 5 times a value, we should be, especially because it says length. See how this says length? So I know that's going in for the L. That means that my width is my unknown because I know my area was 30. So area is equal to length times width. We want to solve for the unknown, and the unknown here is your width. And I actually know what that's going to be. 5 times what makes 30? It's going to be 6. So we want to solve for the width. Okay, stay tuned for my last video, which is going to be a recap of Chapter 1, and you will see a couple of these questions on your Chapter 2 test to review Chapter 1.